Hello, students, and happy March 26th. We're going to start with a do now today about hoodies. I think you'll find that kind of interesting and spark some conversation. And our objective today will be to multiply a monomial by a binomial. So one term, two terms. Essential questions we ask are how do we multiply a monomial by a binomial? And how do I work with multiple grouping symbols? We're going to get some good practice today with that. Our assignment is to complete the do now, complete the 2 pages, complete the exit ticket. If you're a distance learner, you'll submit your work on Teams. If you're an in-person learner, you'll show your work to me to get that credit. For homework, we're going to work on homework 2, multiplying monomials by binomials. Remember, make sure all your Unit 6, we're in Unit 7 now, make sure all your Unit 6 work is complete and turned in by Monday, March 29th. So we'll get back to our exit ticket in a little bit, but let's look at today's do now. I think it's kind of fun. Today is National Hat Day. So I want to know why people wear hoodies. Why do you guys wear these hoodies? Are you hiding something or expressing something, expressing yourself, or just staying warm? But hoodies are a big deal around here, and I want to understand that better. So I would love for you to write something about that right there, and you can talk about it in class. So let's get on to our monomial by binomial multiplication. And when we do this, we want to remember the product rule of exponents, okay? So that would be x to the a times x to the b power equals x to the a plus b. We add exponents. So we're multiplying those exponential terms. We add the exponents if they're like terms. So now, with our first example, we've got x multiplied by the quantity of x plus 4. And we're simply applying the distributive property here. So x times x will be x squared. We're not adding, we're multiplying. So think of that as this is x to the first power. Let me clean that up a little bit so you can get a good look at it. Think of this as x to the first power. We have an invisible exponent of 1 on each of those. If we add those exponents, 1 plus 1 would be 2. Well, now we're also going to multiply x times 4, and that's a positive 4 and a positive x, so that would be plus 4x. In the second example, we're going to multiply 5m to the third through to each one of these terms. Remember, terms are separated by addition and subtraction, okay? So we're going to multiply 5m to the third first times 3m to the second. So 5 times 3 is 15. Now, for the exponential term on the variable, we need to add those exponents. So that would be 3 plus 5, 15m to the fifth. Now we have positive times negative, so it would be negative 5m, and we have an invisible one here, so 5m to the fourth. And then positive 5m to the third multiplied by negative 7 will be negative 35m to the third. And that's how you do it. So let's try a few. So this is like our first example, except we have subtraction here. So please very carefully watch your signs when you do these. So k times the quantity of k minus 9. K times k is k squared. And then k times negative 9 would be negative 9k. Number 2, we're going to multiply 9a by the quantity of a plus 1. So 9a times a would be 9a squared. We're adding those two invisible ones. Then positive 9 times positive 1 would just be positive 9, but we have that a. So these are not like terms. An exponent of 2 is not the same as an exponent of 1. So this is as simplified as we can get it. We cannot combine those any further. So for number 3, we have negative 6p multiplied by the quantity of p to the fourth power minus 8. So negative 6p times p to the fourth will be negative 6p, and we have an invisible 1 plus 4 is 5, minus, well, wait, let's see, we have a negative times a negative, so it's going to be plus 48p. And then number 4, 3c to the fifth multiplied by the quantity of negative 2c minus 5. So 3c to the fifth, well, 3 times negative 2 is negative 6. And c, 5 plus that invisible exponent of 1 is 6. So that's our first term. And then positive 3 times negative 5 is negative 15. And we have our c to the fifth power. So why don't you go ahead and try the rest of the page maybe, and let's see how you do before we get on to some more challenging ones. So number 5, negative 4g squared times the quantity of 2g plus 7, negative 4 times 2, negative 8. G, 2 plus 1 is 3. Negative 4 times positive 7 is negative 28. And then we've got our g squared, and we cannot combine those any further. So it looks like we've got a trinomial here in number 6. So x will be multiplied through to all three of these terms. Remember, terms are separated by addition and subtraction. So x times x squared is x to the third. X times negative x is negative x squared. And x times 3, and they're both positive, would be positive 3x. And number 7, we have negative 3n multiplied by this trinomial n squared minus 2n plus 8. So negative 3n times n squared is negative 3n, 2 plus 1, 3. Negative 3 times negative 2 is positive 6, and we have a 1 exponent on each of those, so that would be n squared. And then negative 3 times positive 8 is negative 24, and we have our n. Final answer. Number 8, we're going to multiply negative 2x to the fourth power times the quantity of 6x squared minus 12x plus 18. So negative 2 times 6 is negative 12, and we have x, 4 plus 2 is 6. Negative 2 times negative 12 is a positive 24. X to the fourth times x to the first would be x to the fifth. And then negative 2 times a positive 18 would be negative 36, and we have our x to the fourth power. And moving on to number 9, we have p squared q cubed to the third is cubed times the quantity of p to the fifth, q to the second minus pq. So let's be careful with our negative sign. So first we have p, we have 2 plus 5 is 7. Remember, this is multiplying, so we add the exponents. This is not raising a power to a power. Then we have q, 3 plus 2 is 5, minus p squared times p is p to the third, and q to the third times q is q to the fourth. And these are not like terms, we cannot combine them. So number 10, they're getting a little more complex, same rules. We look for those invisible ones, both in front of a variable where there's no other coefficient, and as well in the exponents. If there's no exponent, it's an exponent of 1. So let's keep those rules in mind. And 3xy, the x and y of an exponent of 1, as does the 3. But we also have an invisible 1 in front of this quantity of x squared plus xy plus y squared. So 3 times 1 is 3. X times x squared, 1 plus 2 is 3. And then we have our y. That's only the first term. Now we go to the second term, positive 3 times a positive 1, invisible 1 here, is positive 3. X times x is x squared. Y times y is y squared. And then positive 3 times invisible positive 1 again is 3. We don't have an x term, so we'll just write our x, but we have y times y squared, which would be y to the third. And that's our final answer. And that's also, that's how we would write it as well, because we have the higher exponent on the term that's more closer to the front of the alphabet in ABC order would be first. So we look at those x terms, 3, 2, 1. Okay, number 11. So 5r to the second power, s to the second power, times the quantity of negative 2r to the second power plus 3rs minus 4s squared. So 5 times negative 2 is negative 10, and r2 plus 2 is 4. Then we have that s squared. Now 5 times a positive 3 is positive 15, and then we have r2 plus 1 is 3, and s2 plus 1 is 3. And then for the last term, we have 5 times negative 4, which is negative 20, r squared. There's no r term in here, so we just put our r squared. Then s squared times s squared is s to the fourth, because we add those exponents. And then number 12, 3ab times the quantity of 4a squared minus 7b to the third. So 3 times 4 is 12, and a, 1 times 2 is 1 plus 2 is 3, and b just is on its own because there's no b term here. Okay, so now positive 3 times negative 7 is negative 21. We have our a, and then we have our b. 1 plus 3 is 4. And that's your final answer. Let's move the paper up a little bit so we can see what we're doing. All right, let's look at number 13. Negative 7c to the third d to the second multiplied by the quantity of 9c to the second d to the second minus 4c d to the fifth. So we've got an invisible 1 exponent here and a lot going on. So negative 7 times 9 is negative 63. C, 3 plus 2 is 5. D, 2 plus 2 is 4. So that's the first term. And negative 7 times negative 4 is a positive 28. And C, 3 plus 1 is 4. D, 2 plus 5 is 7. And that's the final answer. Number 14, we have 10 m to the fourth power n, and an invisible exponent of 1 there, times the quantity of negative 2 m invisible 1 to the n to the third plus 3n. Now, that's again another invisible 1 exponent. So let's work the first term. 10 times negative 2 is negative 20. M, 4 plus 1 is 5. N, 1 plus 3 is 4. So that's the first term. And now 10 times 3, that's a positive 30. And there is no m over here, so we just write our m to the fourth. And n times n is n, 1 plus 1, 2. Now, they're getting a little bit more complex in the next group of problems. So we need to distribute first and then simplify. And we're going to write our final answers in standard form. So there'll be a few steps here. So negative 2x times the quantity of 3x minus 4 plus 7x. Negative 2x times 3x, negative 6x squared plus 8x, because negative times a negative is a positive, plus 7x. And we can combine the 8x and 7x, so it will be negative 6x squared plus 15x. So number 16, we have to distribute on both sides of the subtraction sign in the middle. So 5w times the quantity of negative 7w plus 3 minus 2w times the quantity of 13 minus 9w squared. So 5 times negative 7 is negative 35. And the w's, we have 1 plus 1, so that would be 2. Now 5w times positive 3 would be positive 15w minus 2w times 13 is 26w, and 2w times negative 9w would be a positive 18w to the third. So let's write it in the correct order, and let's see if we can combine like terms. Well, first of all, we have an 18w to the third. We'll start with that. And then we can combine 15w and 26w to get 30. Actually, it's positive 15 minus 26w. But before we do that, let's write our negative 35w squared. That should be next. And then we'll combine the positive 15w with the negative 26w to get negative 11w. And that is our final answer on this one. So I hope you try a few on your own. Why don't you try 17 through 20? And then we can do the next group together. Okay, so let's see how you did. 17, y times the quantity y plus 4 minus y times the quantity of y minus 3 minus 9y. So we've got a polynomial going on here. Well, actually, once we distribute, we're going to have a polynomial. So y times y is y squared. Y times positive 4 is 4y. Negative y times y is negative y squared. Negative y times negative 3 is positive 3y. And we have our minus 9y at the end. So what can we combine, and how do we write this? So we're going to have our y squared terms first. So we've got y squared minus y squared. So those are going to be eliminated. Then we've got 4y plus 3y, that's 7y, minus 2y, minus 9y. 7 minus 9 is negative 2y, and that's the final answer. So let's look at number 18. 6x times the quantity of 2x minus 3 minus 5 times the quantity of 2x squared plus 9x minus 3. So we have a trinomial. So first we'll start with the left side. 6x times 2x is 12x squared. 6x times negative 3 is negative 18x. Negative 5 times 2x squared is negative 10x squared. Negative 5 times positive 9 is negative 45, and we have an x term there. And negative 5 times negative 3 is a positive 15. So let's look at our x squared terms first. We have 12 minus 10, so that's 2x squared. And then on our x terms, we have negative 18 minus 45. So that's negative 63x. And then we have our positive 15, our constant at the end there, and that's our final answer. And number 19, 2y times the quantity of 6x minus 4x squared y plus 13x squared y squared minus 6. So remember, when you add and subtract, you only combine like terms. We have to have like terms. Let's see if we will after we do this multiplication. So 2y times 6x is 12xy. 2 times negative 4 is negative 8, x squared, y squared. And then we have our 13 plus 13x squared, y squared minus 6. So the only thing we can really combine here, we've got 12xy, we've got the negative 8x squared plus 13x squared y squared. So we've got some like terms there. So negative 8 plus 13 is going to be 5, a positive 5. That's x squared y squared. And then we can write our positive 12xy, which doesn't combine with anything, and our negative 6, our constant at the end. And then number 20, we're going to multiply negative 2 times the quantity of 3m to the third plus 6, and then we will add 3m times the quantity of 2m squared plus 3m plus 1. We have a trinomial there. So negative 2 times 3m to the third is negative 6m to the third. 6 times negative 2 is negative 12. And then moving on to the right side, 3m times 2m squared, it's a positive 6m to the third. And 3m times 3m is positive 9m squared. And 3m times positive 1 is positive 3m. So let's see, we've got negative 6m plus 6m, and those will cancel each other out. So we have 9m squared, that will be the first term we write as we write in standard form. And then we have positive plus 3m, and then our constant, negative 12. And that's our final answer there. So how did you do? I hope you did well. So now 21 through 24, just a little more complex, and then we'll go on to 2 geometric applications. So for number 21, 3v times the quantity of 7v minus 2 plus 3 times the quantity of v squared plus 2v plus 1 minus 3v times the quantity of negative 5v plus 3. You'll find these start to take up a lot of room on paper. So if you need extra scratch paper, get it handy. So 7 times 3, they're positive. That's 21v squared. 3 times negative 2 minus 6v. Now, positive 3 times an invisible 1v squared. So that would be positive 3v squared. Positive 3 times positive 2 is positive 6v. And 3 times positive 1 is 3. And then our last set over here, negative 3 times negative 5 is positive 15. V times v is v squared. And negative 3v times 3 is negative 9v. So what can we combine? Let's look at v2. V squared, we have 21 plus 3 plus 15, that's 39 v squared. And then we have negative 6v plus 6v minus 9v. Well, the negative and the positive 6v cancel. That leaves us with 9v, and all we're left for a constant is the positive 3. Okay, so number 22, 4x squared times the quantity 2x squared plus x minus 5 minus x times the quantity x to the third plus 5x squared minus 3, and then plus 17. So let's start with the left. 4x squared times 2x squared is 8x to the fourth. 4x times 1x is 4x to the third. We have an invisible exponent of 1. 4x squared times negative 5 is negative 20x squared. And then we'll move over to this part. Negative x times x to the third, so negative times a positive is negative x to the fourth. Negative x times positive 5x squared is negative 5x to the third. And negative x times negative 3 is positive 3x. And then we have our 17. So let's figure out how we write it all out. We have 8x to the fourth minus 1x to the fourth. So that would be 7x to the fourth. Then we have 4x to the third minus 5x to the third. 4 minus 5 is negative 1. So that's minus x to the third with an invisible 1 in front of it. Now we have negative 20x squared and no other x squared terms. So that we'll write next. And then we have only one x term. That's a positive 3x and only one constant. And that's our positive 17. And that is what I call a polynomial. 1, 2, 3, 4, 5 terms. It's as simple as we can get it. Number 23, negative 2r times the quantity of r to the third minus 6r squared plus 6 plus 4r to the third minus 5r to the fourth plus 10r. And remember, we have an invisible 1 here. It's like multiplying by negative 1. It simply changes the sign of everything in the parentheses. So negative 2r times a positive 1r to the third is negative 2r to the fourth. Negative 2 times negative 6 is positive 12r, 2 plus 1, 3. And negative 2 times positive 6, negative 12r. So far, so good. Now we have our plus 4r to the third. We just write that. It does not get distributed anywhere. And then minus, we'll work with this section here on the right, minus 5r to the fourth minus 10r. So let's combine like terms. So negative 2r to the fourth minus 5r to the fourth. Negative 2 minus 5 is negative 7r to the fourth. Now, positive r to the third, positive 12r to the third plus 4r to the third. 12 plus 4 is 16r to the third. We don't have any r to the second power terms, but we do have negative 12r minus 10r. Negative 12 minus 10 is negative 22r, and that's our final answer. And finally, number 24, 4b, times the quantity of 2a squared minus 5. What within that is multiplied times the quantity of 3ab minus 2b squared. And then at the end, we have 29ab squared added. So let's start from the inside out. So we'll start with 4b, and then we have our 2a squared. Now we start distributing. Negative 5 times positive 3 is negative 15ab. And negative 5 times negative 2 is positive 10 b squared plus 29ab squared. Okay, so now let's distribute the 4b through. So 4b times 2a squared is 8a, always go in ABC order, squared b. And then 4 times 15, it's negative 15, so it's negative 60. A and b times b is b squared. 4 times 10 is positive 40. B times b squared is b to the third. And then we have our plus 29ab squared. Okay, let's see if we can combine like terms. Well, the 8a squared b is not going to combine with anything. Remember, we're adding and subtracting now, so we have to have exactly the same terms. The negative 60 plus 29, we can combine the ab squared terms. So negative 60 plus 29 is negative 31 ab squared. And then we have that plus 40 b to the third that doesn't combine with anything. We're in an ABC order with descending exponents, standard form. So that's what it should look like. So our last two problems today, before we move on to our exit ticket, we have some geometric applications, and we're going to find the area of the trapezoid. So first, we have to know that we know our formula, the area of a trapezoid. I'm going to write it over here to give me more room to do the problem, is 1/2 the height, which is this dotted line, 1/2 the height times B1 plus B2. Okay, this is our B1 and our B2. So we're multiplying 1/2 the height times the quantity of the top added to the bottom. So let's put this all together. So the area equals, now this is in our formula, the 1/2, and then the height is the 4x squared. And we're going to multiply that times B1, which is this quantity here, to which we will add this quantity B2. So it will be 8x squared plus 3x plus 2x to the third minus x. Okay, so that's our problem. We've set up our problem. So can we combine like terms here and simplify this? Well, we can. We've got the 8x squared, and we can reorganize it too. So we're going to put the 2x to the third first, then the 8x squared, and then we're going to combine 3x minus 1x for 2x. So I'm just rewriting the formula. So I've got 4x squared, and first I'm going to put my 2x to the third. Then I'm combining the 3x minus 1x, so that will be 2x. But before I do that, I want to write this 8x squared and then plus my 2x. Now I can start distributing through these three terms. So 1/2 times 4 is 2x. So let's combine this and make our life easier. 2x squared times, same thing, 2x to the third plus 8x squared plus 2x. Okay, 2x times 2x to the third is going to be 2 times 2 is 4. X, we add the exponents, x to the fifth plus 8 times 2 16x, 2 plus 2 is 4, and then plus, these are all positive, 2 times 2 is 4, and x to the first 1 plus 2 is 3. And this is the final answer. That's what the area equals. Now, we have a clever problem here at the very end where we're asked to find the area of the shaded region only. So here's our strategy. Our strategy is we're going to have the area of the outside, or the outer shaded area, minus the area of the inner area, let's say the inner rectangle. So the area of the outer rectangle minus the area of the inner rectangle, and that's going to be equal to the area of the shaded region. And area is length times width. So we'll start out with the larger rectangle, and that is 6x times 8x minus 1. So 6x times the quantity of 8x minus 1. So furthermore, I'm going to go ahead and let me change the color, and I'm going to put that in brackets. Now, I have to get this smaller rectangle and subtract it. So I'm going to put that in brackets too. So the smaller rectangle is 2x, remember, length times width, 2x times 5x plus 3. So that's our problem. We're all set up and ready to get to work. So let's start distributing. 6x times 8x is 48x squared. 6x times 1 is 6x, and that's a minus. So minus 6x, 48x squared minus 6x, minus, now let's distribute the 2x. 2 times 5 is 10. X times x is x squared. 2 times 3 is 6, and that's a positive 6, and we have our x. So now we're going to subtract. So 48, we can only subtract like terms, okay? So 48x squared minus 10x squared is 38x squared. Let's keep them in parentheses. Okay, negative 6x minus 6x. So it's negative 6 minus 6 is negative 12x. And that's our final answer. We can't combine those terms. They're not like terms. And that is the area of the shaded region of this rectangle. So you've worked pretty hard. So let's go back and just look at that exit ticket. When working with long polynomials, a good thing to remember is, well, first of all, use the product rule. So that would be x to the a times x to the b equals x to the a plus b. And another good thing to remember is distribute carefully through parentheses. And then finally, the last thing I would say is careful with the signs, the positive and the negative signs. So good job. You've really come a long way in algebra. You've worked very hard. I'm proud of your effort. Keep up the good work. Please, please do homework too. I'll show that to you. Here it is, one page. That will give you the practice you need. You have another geometric application. And I also put a mindfulness exercise for you if you're feeling you need it after all this algebra. A little art activity with a hat and a really fun fallen phrase. So thank you for your hard work. And algebra, remember, is the foundation of all your high school math. So you want to get really good at it, and you will with practice, because if you practice, you'll be great.